Good morning, students. Myself, Vijay Shankar from EC Department, Chevron Engineering College. Today, we are going to discuss about the last two topics in the Fourier series properties. The last two properties are Parseval's theorem and the symmetric properties. In the last class, that is in yesterday's class, we completed the properties up to the modulation theorem or multiplication in time domain. The next one is Parseval's theorem. Now you go for the next property, that is Parseval's theorem. Parseval's theorem. See the statement of the Parseval's theorem saying that if x of t is a periodic power signal, the Fourier series are used to analyze for the periodic signals. So we are taking here the signal x of t is a periodic power signal with the Fourier coefficient x of k, with Fourier coefficient x of k. Then the average power in the signal is given by the sum of k equal to minus infinite to infinite, the squared magnitude of x of k. That is, I have to show that the average power P is equal to sum of k equal to minus infinite to infinite, the squared magnitude of x of k. We have to prove this average power of a signal is given as a squared magnitude of x of k with the sum of minus infinite to infinite by taking the x of t is a periodic power signal with the Fourier coefficient x of k. We already know the classification of signals is analog and the discrete. Analog means continuous time signals and discrete time signals. Again, if they are classified, into periodic, non-periodic, even and odd signals, deterministic and random signals, causal and non-causal signals. And another one is the energy and the power signal also. Energy and power signals. Energy in continuous time signal and power also in the continuous time signal. And energy and power in the discrete time signal also. Here we are using to prove the average power of the signal is given sum of k equal to minus infinite to infinite, the squared magnitude of x of k, by taking the signal, the power signal P is equal to, as a continuous, because x of t is a continuous time signal, P is equal to limit t tends to infinite 1 by t integral minus t by the t by 2 x of t square dt. So actually without a limit t tends to infinite 1 by t here, integral minus infinite to infinite or integral t or integral minus t by the t by 2, x square of t is the energy signal. X square of t is energy signal. See, without this limit t tends to infinite 1 by t is only for the energy signal. It is energy. Energy E is equal to, with the limit t tends to infinite 1 by t with energy signal, call it as the average power signal P. By taking this power signal in the continuous time signals 1 by t integral minus t by t by 2, the squared magnitude of x of t dt for periodic signal. For periodic signal, you can take it as a magnitude one. Okay, the magnitude here. And this magnitude we can written as see here the x of squared magnitude of x of t is a combination of a real term signal x of t and the complex signal x star of t. Following my dear students. So actually the combination of x of t into x of t is the x square of t here itself. X square of t is a different and magnitude of x of t whole square is a different. It is x of t square means x of t into x of t. X of t into x of t. But the squared magnitude of x of t is equal to x of t and x star of t. The combination of the real and the complex signals of both. Now, I'm replacing this squared magnitude of x of t square as x of t, x star of t dt. X of t, x star of t dt. How it becomes of magnitude, square magnitude? Because it is a periodic signal. As a definition saying that the power is equal to limit t tends to infinite 1 by t, the integral minus t by t, the t by 2, x square of t dt. As it is a periodic signal, I'm taking the 1 by t, the integral minus t by t, the t by 2, squared magnitude of x of t dt. I'm changing this squared magnitude of x of t as x of t, x star of t dt. In this, we already know the x of t is equal to, is a synthesis equation. X of t is equal to sum of k equal to minus infinite to infinite x of k e power plus jk omega naught t. Analysis equation we already know. Analysis equation is x of k is equal to integral minus t by the t by 2 or within the limits of t. Input is x of t here. X of t e power minus negative exponential jk omega naught t dt. We are using this exponential Fourier series. One is analysis equation, another one is a synthesis equation. Using this synthesis equation, x of t is equal to the sum of k equal to minus infinite to infinite x of k e power jk omega naught t. Taking both sides as a conjugate, on both sides the conjugate becomes of x star of t is equal to whole sum of k equal to minus infinite to infinite x of k e power jk omega naught t whole star. This is by taking the conjugates on both sides for synthesis equation. So in the right hand side, you can see the x of k with this star becomes of conjugate x star of k. And this exponential is a positive exponential. With this conjugate, the positive exponential becomes negative exponential here. Understood, my student? Here, see the sum of k equal to minus infinite to infinite x of k e power jk omega naught t whole star, and x of k with this star becomes of conjugate of the signal or the Fourier coefficient, and positive exponential becomes of negative exponential. X star of t is equal to. Now you can substitute this equation in power p is equal to 1 by t, the integral minus t by to the t by 2 x of t, x star of t is replaced with this signal. The sum of k equal to minus infinite to infinite x star of k e power minus jk omega naught t. Already we have here the dt. So that is in the next line, next page. So now the p is equal to 1 by t, the integral minus t by to the t by 2 x of t, x star of t replaced with the sum of k equal to minus infinite to infinite x star of k e power minus jk omega naught t dt. Now rewrite this expression. The P is equal to, see here, the P is equal to 1 by T, the integral minus T by T, the T by 2. I'm taking the x of t, and here also the t function is there. Take the t power minus jk omega naught t and the dt with respect to dt, whole multiply with the x star of k, the conjugate of Fourier coefficient. You see here the sum of is also there. The sum of k equal to minus infinite to infinite x star of k as another function. See, within the first parenthesis, the equation becomes of 1 by t, the integral minus t by t, the t by 2, x of t e power minus jk omega naught t dt as x of k only. I got the analysis equation saying that 1 by t, the integral t, x of t e power minus jk omega naught t dt. Now this total within the parenthesis what we have becomes of x of k. This is x of k. So sum of k equal to minus infinite to infinite x star of k, and this function as x of k. We already know the combination of one complex function and the real function becomes of squared magnitude. The sum of k equal to minus infinite to infinite, the squared magnitude of x of k. The power average power p is equal to, we got a sum of k equal to minus infinite to infinite, the squared magnitude of x of k. Alright, that only you have to prove the Parseval's equation. Let's see here. If x of t is a periodic power signal with Fourier's coefficient x of k, then average power in the signal is given by the sum of k equal to minus infinite to infinite, the squared magnitude of x of k. We prove that by taking the power signal p is equal to limit t tends to infinite 1 by t, integral minus t by t, the t by 2, x of t square. If it is a periodic signal, that becomes of squared magnitude of x of t. The squared magnitude of x of t also written as x of t into x star of t. By using the synthesis equation, substitute x star of t with sum of k equal to minus infinite to infinite, x star of k e power minus jk omega naught t. After substituting in the power, p is equal to 1 by t, the integral minus t by t, the t by 2, x of t, the sum of k equal to minus infinite to infinite, x star of k e power minus jk omega naught t dt. And rewrite this expression as p is equal to k terms in one side, that is sum of k equal to minus infinite to infinite x star of k, and remaining t terms in the other side, 1 by t, the integral t, x of t e power minus jk omega naught t dt. And this total function, has analysis equation saying the x of k is equal to sum of k equal to minus infinite to infinite x star of k into x of k. We know already the x of k, x star of k represented as squared magnitude of x of k. So now what is the significance of Parseval's theorem is power of the signal can be obtained by squaring and adding the magnitudes of Fourier coefficients. By squaring and adding the magnitudes of the Fourier coefficient. That is the significance of the Parseval's theorem. It is also somewhat important one with the convolution in time and the multiplication in time. It is also called as modulation in time. The last property in the Fourier series, that is a ninth one, symmetry properties. These are not the properties, they simply have the formulas. The first one is, if x of t is a real, given the time signal is real, the frequency signal x star of k is equal to x of minus k. Symmetry for the negative values also. X star of k is equal to x of minus k. If that same signal is imaginary, if x of t is imaginary, then the conjugate of x star is nothing but conjugate. The conjugate of the frequency coefficient or the Fourier series coefficient in frequency, x star of k is equal to minus x of minus k. For real terms of t, the positive value will get, and for imaginary terms, minus x of minus k. Okay. And third one you can see here, the x of t is a real and the even also. It is a real, x star of k is equal to x of minus k. If x of t is real and it is also the even, then imaginary of x of k is equal to 0. When x of t is real, imaginary of Fourier series coefficient x of k in frequency, imaginary of x of k is 0. If x of t is real and odd, the same thing here. If x of t is real, if it is even, imaginary is equal to 0. If x of t is real and odd function, then real x of k is equal to 0. So these are the symmetry properties. If x of t is real, x star of k is equal to x of minus k. If x of t is imaginary, then x star of k is equal to minus x of minus k. If x of t is real and even, imaginary of x of k is equal to 0. If x of t is real and it is odd, then real of x of k is equal to 0. So totally there's 9 properties there in the Fourier series. So what are the similar properties in the Fourier transformation also? For the coming after this completion of the Fourier series, we are getting in the Fourier transformation. In the Fourier transformation also same thing. Linearity property, time shift property, frequency shift property, scaling property, time differentiation property, Parseval's theorem, and convolution time and the modulation time also the same. But don't confuse that. If they ask prove the property or prove the linearity property of Fourier series, means you have to write in the Fourier series only. And mention, or you can prove the property of linearity property of Fourier transformation, means you have to see that Fourier transformation only. The proof is same for Fourier series, Fourier transformation, and also the last 2 units also we have, that is the transformation and the Laplace transformation. So as per for third year students of R16, but second year students it is both the same. But in that also the name of the properties is the same. The linearity, time shift, frequency shift, time differentiation, convolution time, and the convolution modulation or the multiplication. The naming is different, but you have to prove by using the Fourier series, by using the Fourier transformation, and by using the Laplace, and by using the Z transformation. Understood? These are all, it is converting of time domain function to the frequency domain functions. Okay. Let us see some examples on the Fourier series. The first example, find the trigonometric Fourier series. Find the trigonometric Fourier series for the periodic signal shown. Simply they are giving the one periodic signal and you have to find out the trigonometric Fourier series. Fourier series are classified as a three. One is trigonometric Fourier series, second one is compact trigonometric Fourier series, and third one is exponential Fourier series. All the properties we use exponential Fourier series formulas only, analysis equation, the synthesis equation. Okay, my dear students. So for this, they are asking for the given periodic signal, find the trigonometric Fourier series. What are the trigonometric Fourier series? The three. A of 0 is equal to, and A of k, and the B of k. Finding out of all the A of coefficients, A of 0, A of k, and B of k, you can substitute in the x of t equation. What is the x of t is equal to A of 0 plus A of k with coefficient, coefficient is a cosine function, and B of k is a coefficient for the sine function. Following, my dear students. X of t having the three terms. The three terms, in that three terms, the first term is the A of 0, and second term is having a coefficient of A of k with a cosine function, cos k omega naught t. And the third term, B of k, is a coefficient for the sine function. So first of all, you can find the A of 0, A of k, and the B of k, all the terms, nothing but is the coefficients. After that, we can substitute in the x of t. But first of all, from the given table or the given figure, periodic signal, you see here, this is an exponentially decaying function from 0 to 0.5. Observe here, my dear students. 0 to 0.5. Again, it is repeated with the 0 to 1. Again, it is repeated from 1 to 1.5. And again, it is represented from same from 1.5 to the 2. And in the negative real axis also 0 to minus 0.5 and minus 0.5 to 1 and 1 to 1.5. For every time period of 0.5, it is repeated. Okay, with equal interval of time. With equal interval of time. With what period here? Point. You see, the t is equal to here, the period t is equal to 0.5. For every 0.5, the 0.5 to 1 is a 0.5, 1 to 1.5 is also 0.5, 1.5 to the 2 is also, the period is a 0.5. And the given function is, what is the given function? X of t. Exponentially decaying function. Exponentially decaying means e power minus t. E power minus. When exponentially rising means e power plus. Okay. So these are the two given terms from the given periodic exponential signal. The t is, capital T is 0.5 and x of t is equal to e power minus t over one period. Over one period. See, what is the formula for the A of 0? We already proved the functions, the trigonometric Fourier series. A of 0, A of k, B of k. A of 0, the formula is a 1 by t, the integral t. Integral t, x of t dt. What is the integral here? Initial value is a 0, final value is a 0.5. So the integral initial value is 0 I take, and final value is a 0.5 because the time period is a 0.5. And similarly, the 1 by t here, 1 by 0.5. The x of t is negative exponential because it is a decaying from the magnitude 1 to goes to the 0. E power minus t dt. Now the 1 by 0.5, what is the integral of e power minus t? E power minus t by minus 1. The coefficient of t is here, the minus is there, the minus 1 divided by the minus 1. Lower limit is 0, upper limit is 0.5. Okay. So after calculating this function, 1 by 0.5 means 1 by 1 by 2. Nothing but is a 2 function. See, 1 by 0.5. If you have the calculators, take your calculators and find out the value. Here the minus is there. I'm keeping the minus here. The minus e power minus, what is the upper limit here? The minus 0.5 minus e power minus 0 is a function is equal to, that is equal to minus, what is the value here? The 1 by 0.5 means 1 by 1 by 2. Totally it is the 2. 2 into e power minus 0.5 minus anything power 0 is a 1. 1. Definitely it is a e power minus 0.5 is less than the 1 only. Less than the 1. So here the minus is there, here also the minus, greater value having the minus is there. Minus into minus definitely becomes of the plus. You find out e power minus 0.5, what is the value, and simplify this one. Definitely you'll get the 0.7869. Take your calculators and find out the e power minus 0.5 value. Definitely that is a positive value and it is less than the 1. Understood? So subtract these two functions and multiply with the 2. Minus into minus is becomes of the plus. 0.7869 is a A0 value. A0 value, A of 0 value is 0.7869. Then you go for step 2, calculate the A of k. A of k, that is the second one here, A of k. What is the formula for the A of k is equal to the 2 by t, the integral t, x of t. X of t is a coefficient of cosine function, my dear students. X of t in the cos k omega naught t dt. What is the x of t here? E power minus t. And t is equal to 0.5. So we write as 2 by t as a 2 by 0.5. 2 by 0.5. The limitations is the same, 0 to 0.5 here. X of t cos k omega naught t. What is the cos k omega naught t? Omega naught is equal to 2 pi f. We already know 2 pi f. F is a inversely relation between of the time is 2 pi by t. 2 pi by t. What is the t here? The time period is a 0.5. So 2 by 1 by 2. Total it is a 4 pi. So omega naught is equal to 4 pi. Substitute here cos k 4 pi into t dt. And x of t is equal to e power minus t. X of t is equal to e power minus t cos 4 pi kt into dt. Now directly if it is a e power minus t, you can apply the integral, or otherwise integral cos is there, you can directly apply the integral. Integral cos is a sine, or integral sine is a cos with some change of the positive and negative. But it is a combination of exponential and cosine function. Combination of exponential and the cosine function. See here the trigonometric function e power ax cos bx into dx. Integral e power ax cos bx into dx. So these are equation we get in the M1 or M2. We already learned in the first year. Or in the trigonometric series, trigonometric function, integral e power ax cos bx. So what is the a here comparing of these two functions? A is equal to -1 as a t is x here. A is -1 and the bx, x here the t, so what is the b here? 4 pi k. So b is equal to 4 pi k. The formula for the e power ax cos bx dx is equal to e power ax by a square plus b square whole multiply with a into cos bx plus b into sin bx. Once again you can see the integral e power ax cos bx dx is equal to e power ax by a square plus b square whole multiplied with a cos bx plus b sin bx. Substitute the values of a as -1 and the b as 4 pi k in this equation to get the a of k value. Let us see. I am using this one. E power ax cos bx is equal to the same value. A of k is equal to 4 whole multiplied with e power a. What is the a here? -1. So e power -1 into t by a square plus b square. What is the a here? -1 whole square is a positive value plus b square. What is the b? 4 pi k whole square and whole multiply a into cos bx. Okay, a into cos bx plus b into sin bx. So a, what is the a here? -1. A is -1 cos 4b 4 pi k into t plus b sin bx. What is the b here? 4 pi k sin bx 4 pi k into t. Okay, and totally it is an integral of e power ax cos bx into dx as with the limits of t here 0 to 0.5. 0 to 0.5. So first of all, you can substitute the upper limit in this equation wherever the t is there. 4 into e power minus t. E power minus t, upper limit is a 0.5. E power minus 0.5. 1 plus 4 pi k whole square whole multiplied with minus cos 4 pi k. The t is 0.5 here. 4 pi k sin 4 pi k. Here also the t is there, 0.5. It is only the upper limit. But to substitute the lower limit, use the minus e power minus 0 or plus 0, whatever it is the same only. E power minus 0 divided by 1 plus 4 pi k whole square whole multiplied with the minus cos 4 pi k into 0 plus 4 pi k into sin 4 pi k 0. And this equation is for upper limit and this equation is a lower limit equation. Simplify this one. Okay, e power minus 0.5. What is the e power minus 0.5 value? Is 0.606, my dear students. 0.606. You can multiply this 4. In both the cases, the denominator is the same. 4 by 1 plus 4 pi k whole square. And the cos, here the 4 is there. 0.5 is 1 by 2. So 1 by 2 into 4 is a 2. So minus cos 2 pi k plus 4 pi k. And here also 1 by 2. It becomes of sin 2 pi k. What about the second term here? Cos 0 is equal to, what is the cos 0 here? Cos 0 is a 1. Cos 0 is a 1 and sin 0 is a 0. So the last term what we have here, it is a 0 value. 0 means 4 pi k sine 0 is 0, and this value is a 1 minus, and here the minus into minus is there, becomes of plus. Following my students. So individually you can observe here. It is a minus, minus into minus is becomes of plus, and cos 0, the value is a 1. And sine 0 into 4 pi k, it becomes of totally the 0. These are the two terms of the lower limit values. And upper limit also you can observe here. The first one is minus cos 4 pi k into 0. 4 pi k into 0 means the value is here, it is a 1, already said. Cos 2 pi k, minus cos 2 pi k plus 4 sine 2 pi k. What is the sine 2 pi k? Sine 2 pi k is also the 0 itself. Following, sine 2 pi k is a 0. Only the remaining term, here the value is 1, and this value is a 0, and this value is a 1, and this value is a 0. Okay, 1 here, and this one is a 0, and here the 1 and the 0. Now this 0.606 is multiplied with 1, we get the minus 0.606, and this value is a 0, here the 0, and this value is a 1 and 1, and this value is a 0, we have the 0. Whole multiplied with the 4 pi, 1 plus 4 pi k whole square. Simplify it is, denominator is the same, 1 plus 4 pi k whole square, 4 into 1 minus 0.606. You find it this one value by using your calculators. 1 minus 0.606 multiplied with the 4, the totally the A of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square. Understood? So these are 4.606 is only multiplication factor of these two values, my dear students. Don't multiply this 4.606 for this one. Is only the multiplication factor of here e power minus 0.5 is the first term all. But the second term e power 0 is a 1. E power 0 is a 1. So here the value is 1. Denominator is the same for the two functions. Is a one factor, is another one. Only the e power minus 0.5606 is multiplication factor of these two terms only. So I multiplied 0.606 with 1 as minus 0.606. Sine 2 pi is a 0 value, and 1 into cos 0. Minus into minus is a plus, and sine 0 is a 0, so 1 into 0 is a 0. Okay, so we got A of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square. We got A of 0 and A of k. Similarly, the third one you can find out B of k also. What is the B of k here? As of x of t is a coefficient of sine function. So B of k is equal to 2 by t, the integral t, x of t sine k omega naught t. Here also the omega naught is a 2 pi f, 2 pi by t. T is 0.5. So 2 pi by the 1 by 2. Total it is a 4 pi. So omega naught is becomes of 4 pi into t. K is already there. What is the x of t e power minus t? And the limitations is from 0 to 0.5 as given of exponential signal, and remaining is a periodic signal, so 0 to 0.5. And this value is 1 and x of t. As a periodic signal, it is repeated as of exponentially decaying function. So 2 by 0.5 with the limitations of 0 to 0.5 e power minus t sine 4 pi k into t dt. Sine 4 pi k into dt. Here also, but you see here, now use this formula e power ax sine bx. E power ax sine bx. Why? It is a e power minus t sine bx. Here also a is equal to minus 1, b is equal to 4 pi k. The equation is different. E power ax sine bx is equal to e power ax by a square plus b square into a sine bx plus b sine b cos bx. The interchange of this one. Okay. After the simplification, the 4 into integral 0 to 0.5 e power minus t sine 4 pi k into dt, you can apply the integration as of substituting of upper limit and the lower limit. Finally, you'll get 6.32 pi k whole divided by 1 plus 4 pi k whole square. For a of k, you'll get the constant value 1.576, and for the b of k, you get the variable of k, 6.32 pi into k whole divided by 1 plus 4 pi k whole square. All these three terms, a of 0, see we got the a of 0 is a 0.7869, and a of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square, and b of k is equal to 6.32 pi k whole divided by 1 plus 4 pi k whole square. All the three terms, the three equations you can substitute in the x of t is equal to, I already told, the Fourier series having the coefficients a of 0, a of k and b of k. A of 0 is a constant, a of k is a coefficient of cosine function, and b of k is a coefficient of a sine function. So x of t is equal to a of 0 is a 0.7869 plus sum of k is equal to 1 to infinite. Why it is a 1 to infinite we got here? When k is equal to 0, cosine function is equal to 1. When k is equal to 0, sine function is a 0. So there is no any value for the k is equal to 0 for the sine function. For the cosine function we have 0.7869. So k is equal to 1 to infinite. The a of k coefficient we got 1.576 whole divided by 1 plus 4 pi k whole square cos k omega naught t plus sum of k is equal to 1 to infinite b of k here. B of k is equal to 6.32 pi k 1 plus 4 pi k whole square into sine function, sine k omega naught t. This is a trigonometric Fourier series equation after substituting the a of 0 coefficient, a of k coefficient and the b of k coefficient minus. Understood? It is very important example, my dear students.